Hey everybody, it's hwsteele, and today is December 8th, 2020, and the holidays are about to be upon us. This is probably the busiest time of year for me, that and when school starts for the children in August. But right now, I am extraordinarily busy, and that's why you have not seen as many videos here on YouTube, and I will continue to be busy until the very beginning of next year. But I really wanted to go ahead and get a video out, so I was thinking, what should I do a video about? And then the topic came to me. The whole holiday season for me is about family and our relatives and visiting people we haven't seen for months or even almost a year, talking to them, celebration kind of thing. And the idea of the whole visiting and communicating with the relatives brought something to mind that I thought would be really interesting for some folks anyway. And that is relativity, as in Einstein's theory of relativity, specifically his special theory of relativity, because it kind of fits in a little bit with W.D. Gann's theory on time and price. So time is relative, right? Like I've got this beautiful picture of a butterfly. I took this picture last year, and it was not wintertime. I mean, technically it's not wintertime now, but it will be in a couple of weeks. It was the opposite time of year, as in spring and summer. But anyway, the whole idea of relativity. Let's look at something here. Pretty much everybody who watches this channel of mine on YouTube is interested in W.D. Gann, William Delbert Gann. And most people who study Gann know that he was born on June 6, 1878, and he passed away on June 18, 1955. He was 77 years old when he passed away. But what's really interesting to me is that Albert Einstein was born about 9 months later in 1879 in Germany, and then he passed away the same year that Gann did, 2 months before to the day, on April 18th, 1955. So he was 76 when he passed away. So these two guys, Albert Einstein and W.D. Gann, were alive at almost exactly the same time for almost exactly the same amount of time. And I always thought that was interesting. But what's even more interesting is the fact that Albert Einstein, in I believe it was 1905, he published what basically is his special relativity. Let's click on here and look here so I can be a bit more specific. I know it's down here. Okay, in 1905, his special relativity, or special theory of relativity. And basically, the idea of that theory of his is that time and space are kind of woven together. They're part of the same thing. You think of space, and the reality is, in the theory, that time and space are the same thing, and that a measurement in one can also be a measurement in the other in most cases. And I'll explain that a little bit, because a lot of people don't really understand, even on a very basic level, relativity or special relativity, because the general theory of relativity actually takes into account gravitational, or not gravity, but mass that creates the theoretical gravity fields by curving space-time. But a special relativity kind of deals with just space and time without all the other stuff that comes up in his general relativity theory. But anyway, so this came out in 1905. He published it. It was September of 1905. So it's entirely possible that it helped flavor W.D. Gann's ideas about the stock market. So let's look a little bit at a very basic, overly simplified idea of special relativity. I'm going to bring up the Paint program from Windows, and I'm going to draw a little square here. Let me try and get it Trying to make it as square as possible, and right there. Oh, I missed it by 1 pixel. So the square is almost exactly perfect right there, but that's good enough. And then I'm going to draw approximately the halfway point within the square. And all I'm really doing is creating a grid here, and we're going to draw the halfway point right there, and then we'll draw the halfway point right here, which gives us the quarter point, and the quarter point right here, which we can scoot that over a little bit. And like I said, I'm just hand drawing this, so it is definitely not exactly perfect, but it gives us the very basic idea. So here we have a grid, and we'll call this space-time. So we'll say that, let me put a little label here, this is 0%, and then this is 100% up here at this corner, and then again we have 100% at this corner right here. Okay, so 0, 100%, 100%. Now on this side we'll say time is represented by the vertical scale, or the y-axis of the chart, and we'll say that space is represented by the x-axis right here. So what this little graph is going to show is actually velocity through space and velocity through time, because the very basic idea of the special theory of relativity is that everything that has mass and matter moves through space and time at the speed of light. Now the basic idea is that space and time are part of the same thing. They exist together, and I won't go into all technical details and everything. I'll try and keep this as simple as possible, and you're not going to want to write a paper for school off of this information that I'm giving you, but it's to give you the very basic idea. So the theory is that at all points that at every instant that you exist, no matter what you are moving through time and space at the speed of light. Okay, so and this is 100% of the speed of light, and this is 100% of the speed of time in the speed of light. So let me back up and explain that just a little bit. If you're at a complete standstill, you're right here in the graph at 0, no movement. You're not on a planet orbiting around the sun, orbiting around a galaxy or anything like that. You're just completely still right here. If you're moving at the speed of light, then on the graph it shows right here. Now the thing to remember is, if you move at the speed of light, that does not mean that you're everywhere at once. It just means you're moving at the maximum theoretical speed that you can move through space. Now time works the same way. This is, at this point on the graph, this is moving through 0 time. There's no time passage whatsoever. But moving through, or this point of the graph right here, is moving through time at the maximum speed possible that you can move through time. Or in this theory, Einstein's special theory of relativity, you're essentially moving at the speed of light through time. Now, the thing is, just like there's a maximum speed that does not mean you're everywhere at once, it's just the maximum speed through space, there is a maximum speed you can move through time, and it doesn't mean that all time has happened at once. It's just the maximum limit to the speed at which time will pass. So with that understood, the basic idea is you are somewhere within this grid at all points in time. You can never be moving faster than the speed of light through space, because that uses up the entirety of your velocity. Because remember, in this theory of Albert Einstein's, everyone is always moving at the speed of light. Everyone moves at the speed of light. Everything moves at the speed of light. But it's moving at the speed of light through space-time, not just through space. So however much you don't use of the speed of light through space, you're going to use through the speed of light of time, in time. So a consequence of this is if you're moving at 100%, if you're moving at the speed of light through space, so 100% of that velocity that everything is moving is used to go through space, you have no more of that velocity left to go through time, so time will stand still, relatively speaking. And the opposite of that is true. If you are not moving at all through space, you're using 100% of that velocity of the speed of light to move through time, right there. So now the thing to realize is we're not at a complete standstill, right? We're on Earth, it's rotating, it's revolving around the sun's moving around the galaxy's moving around our supercluster's moving around the universe. So there's quite a bit of velocity that's added up there that we're actually moving through space. But the thing is, that velocity is extremely fast for what we're able to actually produce ourselves in velocity through space. It's nowhere near the speed of light. It's much less than 1% of the speed of light. So what that means is that almost all of the speed of light that we have, the velocity, since everything in this theory is moving through space-time at the speed of light, almost all of that speed of light velocity is being used to move through time. So we are very, very close to moving through time at the maximum possible speed, according to this theory. And at first you might think that it's kind of a linear relationship that would look like this, and you can tell it's not a perfect, I didn't draw these graph lines perfectly here, but the 45-degree angle that would come down would be a linear line, meaning if you're moving at 50% of the speed of light through space, that would leave you with 50% of the speed of light left to move through time. But it doesn't actually work like that. It's an exponential curve, really. And the reality is that if you were moving at 25% of the speed of light, you would still be somewhere in the neighborhood of right around here, right up almost at 100% of the speed of light through time. So time would still be going, even if you were going, this is how many thousands of or millions of miles per hour, a quarter of the speed of light, there would only be a very slight dilation in time, so that it would be something along the lines of, for every 100 seconds that a person that's at a complete standstill experiences, there would be like 98 seconds experienced by the person moving 25% of the speed of light. So there's very little loss of time momentum at this point. At the 50% point, it would be something probably like this right here. You would have lost still just a very small amount. It might be a little bit lower on the graph in reality. And the thing is, so because of the fact that it's an exponential curve instead of a linear curve like this, you have 50% of the velocity of the speed of light here, but that still allows you to experience something around the neighborhood of 90% of the velocity through time. And then when you get around here, you'd be somewhere in the neighborhood of something like this. And in this last 25%, between 75% total of the speed of light and 100% is where the time just drastically slows down to the point where when you're traveling at 100% of the speed of light through space, there's no velocity left to travel through time. So you're at zero right there. And the reason that this is shaped like this is because of the shape of the curve. And it's something that you might find kind of familiar. So let me create this curve right here. Okay. Give me a second here. And again, this is not perfectly to scale. This is just my shorthand version of it right here. All right. That's not particularly good, but it gives you the example that we need right here. Oh, good Lord. I've just drawn it for half scale. Drew it for half scale. Okay, so there is the actual factual curve representative. It's actually, if you complete the mathematics and find the curve through space-time, you'll find that it's a quarter of a circle there, and that it will eventually curve back on itself, and that has implications that go way beyond what I'm talking about in this video. But the point is, it's just a circle here. The mathematics come out to a circle so that in this part of the arc right here, we lose very little time velocity for all of this space velocity that we're gaining. And then at the very end, we lose a dramatic amount of time velocity for the little bit of space velocity that we are gaining. So it's kind of like, you can think of it as the mirror opposite of what's happening here is what's happening here. So now, I'm not going to go into too much more detail because I just wanted to point out the very basics of this theory of Albert Einstein's. And you can probably, most people who are familiar with Gann and his scaling of charts and angles and all that kind of stuff, can probably already start to see some correlations here. If you go back to August, I don't remember the exact date, but I did a video called Something to Think About, and I'll put a link to it in the description if you're at all interested in going to look at it. But understanding this in a basic form, as explained in this video, you can go back to that video and you'll probably think about it slightly differently now. Maybe. I don't know. Hopefully. At the very least, I hope this gave you a little bit of something to think about in application to the stock markets or commodity markets, forex markets, and all that kind of stuff. So, like I said, this is not the information you want to use to write a book report about the special theory of relativity, but it gives you the very basic ideas of what Einstein was talking about or theorizing with this. And it doesn't talk about the special theory of relativity does not deal with the time dilation that occurs from mass being introduced into equations. There's a very famous example that's given where you put a bowling ball on a trampoline to talk about space-time being curved around mass, and the bowling ball is supposed to represent mass, and of course the trampoline represents space-time. But it's actually if you understand the theories of Albert Einstein's, then you realize that this is actually the exact opposite of what's happening in his theories, because the trampoline mesh right here gets stretched out so that the mesh is, if this were a representation, this graph here of the trampoline mesh, when the bowling ball is put on it, these get stretched out and the squares, the lines would be further apart. But in reality, what happens in Einstein's general theory of relativity, and when there's mass, the mesh gets pulled together tighter where the mass is. Like I said, it's extraordinarily basically explained in this video, but I really, in conjunction with that video from August, the Something to Think About video, I really think that some of you will be able to significantly benefit from doing some thought experiments with this information. So anyway, let me go ahead and end the video here. I'm going to also let you know that I am going to try to get one more video out before the end of the year, but there's no promises because my schedule is just jam-packed with all the holiday stuff and a few other business things that I have to deal with. So I will hopefully talk to you before the end of the year. I will definitely talk to you in the next video, but hopefully it will be before the end of the year, a little before Christmas. So just in case I'm not able to, have a wonderful holiday season, stay safe, and I will talk to you in the next video.